Hi everyone, so here's the challenge question from last lesson, and I'd like everyone to make sure that they've got a copy of this, a correct copy of this in their notes. If you've had a go at this one already, then you can mark it and correct it if you need to. If you haven't had a go of it already, then please put this in your notes today. Okay, so the first thing we're going to do is draw a diagram so I can have a visual representation of this question. We can see what's going on. So the length of a rectangle is 20 centimetres longer than its width. So the first thing I'm going to do here, I'm just going to let the width be x. Okay, so I'm just going to, you don't need to say that in the exam, but I'm just going to say that on here so that you can see what I've done. I'm going to draw my diagram, so just a rectangle. And we've got, I'm going to call my width x, and then my length is 20 centimetres longer than the width, so that's going to be x plus 20. And the other bit of information I'm told is that the area here is 1,000 centimetres squared. Okay, so that's the start of our question, setting that up. And now let's have a look at solving this. So it wants us eventually to find the width and the length. So basically I want to find x, and then I can add 20 to it to find the length. So let's do this. My area is equal to 1,000, and my area is going to be length times width, so x times x plus 20. So that's going to be equal to 1,000. Expanding this bracket, x squared plus 20x. And then let's take 1,000 from both sides to collect everything on one side and get 0 on the other, because that's what we need when we're solving a quadratic. So now I've got my quadratic set up, and then we're doing completing the square method in all of this. So let's then go through, complete the square on this. So we need to just consider completing the square on this part, leave the minus 1,000 alone. This then is going to become x plus half the coefficient of x. So x plus 10 all squared. And if I did FOIL rule on this, if I wrote out x plus 10 times x plus 10, I'd get x squared plus 10x plus 10x, so 20x in the middle. And then I'd have a plus 100 that I don't want here. So I'm going to take that extra plus 100 off. And then this expression would be exactly the same as this first green bit in this expression here. And then don't forget our minus 1,000 at the end. Okay, so now let's see what we've got. We've got x plus 10 all squared minus 1,100 is 0. Rearranging this then, again, adding 1,100 to both sides. So x plus 10 in a bracket squared is equal to 1,100. And then this expression squared gives me 1,100. So take in the square root, and don't forget that extra step that it needs to be plus or minus the square root of 1,100, because then this value squared would definitely be positive, so that's okay. And then I'm going to take my 10 and subtract 10 from both sides here. I'm just going to move this up slightly. So subtract 10 from both sides. So x is going to be minus 10 plus the square root of 1,100, or x is going to be minus 10 minus the square root of 1,100. So let's just get some values on that, because I want to find out the length of this rectangle, so I don't want to leave it in surd form here. So minus 10 plus the square root of 1,100. So that's going to be 23.1662, or on this side, let's just edit that. Take the minus there, and that's going to be minus 43.1662. Now at this point, if this question was just solve this algebra, solve this equation, then both of these answers are fine. But because this is a real life type of situation, a practical situation, this answer's no good now, because x is a length, it's a measurement, so I definitely can't have a negative length, so that's a contradiction. We get rid of that answer, and so that means then my width, to answer this question, my width is 23.2 centimetres to 1 dp, and then my length must then be x plus 20, so 20 added onto this, 43.2 centimetres to 1 dp, and I'm just going to check, yeah, there's my correct answers, 23.2 and 43.2. So as I say, if you've had a go at that question already, you can mark it now and look through your working. If you didn't, then please get that challenge question into your notes today.